Today, we're diving into a story that honestly feels like it's been ripped from the pages of a graphic novel. It's about Ada Lovelace, a 19th century countess who didn't just glimpse the future. She basically wrote the source code for it, for a computer that wouldn't even exist for another 100 years. And our story starts not with some complex machine, but with a dream. When Ada Lovelace was just 12 years old, she decided she was going to fly. Now, this wasn't just some daydream, no way. She got methodical. She studied the anatomy of birds, she tested out different materials for wings, and she put all her research into this illustrated guide she called Flyology. And right there, that one story tells you everything about how her mind worked. It was this perfect, incredible mix of wild, soaring imagination and cold, hard scientific discipline. So, you have to ask, where does a mind like that come from? Well, to really get Ada, you have to look at these two massive, opposing forces that basically defined her entire life: pure reason and pure romance, all thanks to her very, very famous parents. Okay, so on one side you have her dad, Lord Byron, the ultimate romantic poet, right? All passion, chaos, and raw imagination. And on the other side, you've got her mother, Lady Byron, this brilliant mathematician. In fact, Byron himself used to call her his princess of parallelograms. Now, she was terrified that Ada would inherit her father's madness, so she pushed her hard into math and logic, trying to stamp out any spark of that poetic wildness. And that tension, that was the core conflict of Ada's childhood. But here's the amazing thing. Ada didn't choose a side. She didn't crush her imagination in favor of logic. She fused them together. She developed this whole personal philosophy she called poetical science. For her, imagination wasn't the opposite of reason. It was, and this is her term, the discovering faculty. It was the very thing that let us explore the unseen worlds around us. It was a perfect marriage of her two inheritances. So armed with this completely unique worldview, Ada dives into the scientific scene of Victorian London, and that's where she meets the man who would absolutely change the course of her life, Charles Babbage. So picture this. It's 1833, and a 17-year-old Ada is at a party. She gets introduced to Babbage, and he shows her this prototype of a calculating machine called the difference engine, and she is instantly hooked. That meeting kicked off this incredible friendship and intellectual partnership that would last a lifetime. And yeah, her life went on. She got married, had kids, became the Countess of Lovelace. But that fascination with Babbage's machines, it never went away. It just grew, and it all led to one specific translation project that would become her true legacy. And you know what? Babbage was just as impressed with her. He saw that she wasn't just some math whiz. She was a kindred spirit who could see the profound, almost artistic beauty in his work. He even gave her this amazing nickname, the Enchantress of Number. I mean, that just says it all, doesn't it? It perfectly captures his total admiration for her one-of-a-kind mind. And this partnership is where things get really interesting. It led to her greatest work, a series of notes that went way beyond just explaining something. They were basically a prophecy. So here's how it all went down. In 1842, Ada gets this pretty straightforward assignment: translate an article about Babbage's new, even bigger idea, the analytical engine. But for Ada, a simple translation was never going to be enough. She just started adding things. Her own thoughts, her own ideas, her own insights. These additions grew and grew, becoming this huge series of appendices, simply labeled Note A through G. And I really want you to let the scale of this sink in. Her notes weren't just a few footnotes. By the time she was done, her additions made the published work 3 times longer than the original French article she was just supposed to translate. She didn't just annotate it, she completely took it over and transformed it into something new. And buried deep inside this huge text, in the very last section, Note G, was something the world had literally never seen before. She wrote out this incredibly detailed, step-by-step process, an algorithm, for how the engine could calculate this really complex series of numbers. Today, we know it as the world's very first published computer program. Okay, writing the first ever computer program that's incredible, right? A total game changer. But believe it or not, that wasn't even her most important contribution. Her real genius was in seeing what this machine could one day become. Which brings us to the biggest question of all. What was this huge visionary leap she made? What did Ada see that set her apart from everybody else, including the guy who invented the machine in the first place? Well, for Charles Babbage, his amazing analytical engine was, at its heart, the world's greatest calculator. Its job was to crunch numbers. to solve really hard math problems with perfect accuracy. Its whole universe was the universe of quantity and numbers. But Ada saw so much further. She had this incredible light bulb moment. She realized the machine didn't care about numbers. If you could represent anything with symbols, like musical notes or letters of the alphabet, then the machine could process anything. In that one sentence, she's laying out the conceptual leap from a calculator to a general-purpose computer. She's literally describing a machine that could compose music. And she came up with this brilliant analogy to explain it. She said the analytical engine weaves algebraic patterns just as the jacquard loom weaves flowers and leaves. See, the jacquard loom used punched cards to create complex patterns in fabric. Ada saw that Babbage's engine could do the same thing, but with algebra, with logic, with symbols. It could weave anything: music, art, language. It wasn't just a number cruncher. It was a symbol manipulator. So what happened to this incredible vision? You'd think it would have changed the world overnight. Well, it didn't. For almost 100 years, her work was basically forgotten, only to be rediscovered right as modern computing was finally starting to catch up to her ideas. Of course, history's never that simple, is it? There's been a long-running debate about just how much of this was really her. On one side, you have skeptics who argue that she was basically a brilliant promoter for Babbage's ideas. But on the other side, you've got defenders who say, yeah, Babbage had the hardware concept, but Ada was the one who developed the software concept, that clear, powerful vision of what computing could be, something Babbage himself never fully articulated. But look, no matter where you fall in that debate, her legacy today is just massive. The U.S. Department of Defense named a whole programming language, Ada, in her honor. We celebrate Ada Lovelace Day every October to highlight the achievements of women in science and tech. But most importantly, she will always be the first person who looked at a machine for doing sums and saw the infinite potential of a modern computer. You know, maybe the best way to wrap this up is to just let Ada have the last word herself. It's such a bold statement, full of confidence and an incredible amount of foresight. She knew. She knew she'd seen a future that no one else could even begin to imagine. And today, with our entire world woven together by those very algebraic patterns she talked about, it's pretty clear that time has, without a doubt, shown she was absolutely right.